Hello, this lesson is 11.7 and this is our part 2 of our graphing in this particular chapter. And so if I were to copy something, if you're taking notes, writing things out, these are the things I would copy. I would not necessarily copy what I already have up here on the chalkboard. It's just for reference. So when we did lines briefly in chapter 7, and we looked at linear equations, I just want to recall for you that not all lines come in the same form. There can be multiple different forms that we write the same type of equation or the same type of function. And so when we did linear equations, we made reference to slope-intercept form that you use for graphing, standard form, which we didn't use that much in our class, and point-slope form, which we utilized when we looked at some of our application problems. The same thing happens with quadratic functions. There is more than one form. The two forms that we're going to look at are the vertex form, which is what we saw in 11.6, and the other form that we see is standard form. And notice the similarity here between standard form in this case for a line and standard form here. You'll notice that it's very similar. All right. So when something is given to us in vertex form, we already went through all the steps of graphing. When something is given to us in standard form, we need to learn how to manipulate this form so that it looks like this. And the way we're going to do that is known as completing the square to put in vertex form. So if you skipped the lesson from 11.1 on completing the square, there's one part that's a little bit different, but more or less the steps are the same. So give yourself permission to go through more than one example with me because this can be a little bit tricky. And it's probably better if you just stay with it and watch 2 or 3 examples at once. So our first example looks like this. And notice our goal is to change it once again from looking like this to looking like something that we can graph. And once it's in vertex form, then you are going to refer back to all the stuff we learned in 11.6, finding the vertex, the axis of symmetry, to go ahead and graph. All right, so here are the steps. The first thing you're going to do, just like when we completed the square, this is a 1. All right, but right now I'm going to have us put one blank spot here, plus 4, and put a blank spot back here. Notice my equal sign is there. So when we completed the square in 11.1, the equal sign was in the middle. So if we added 3 to one side, we added 3 to the other side. My scale is a little bit strange. Now my equal sign is way over here. So notice both my spaces are on the right-hand side of the equal. So if I do an operation for this space, I'm going to do the opposite thing for this space so that I rebalance out my equation. Bear with me. All right, so when we completed the square, we looked at that number right there. We took half of that. We got -3. We square it. We end up with a +9. That number goes in the first space, +9. If I add 9 right here, in order to keep that scale balanced, I am going to put a -9 right here. These two numbers, 100% of the time, are going to be opposites. So make a note of that. It's not always going to be a positive-negative situation though, so don't memorize that because then we're jumping ahead to some of the weirder examples. All right, this can be factored. X squared minus 6x plus 9, two numbers that multiply to 9 that add up to -6, x minus 3 quantity squared. Remember, this number is always that number. So that's another way to look at it. You have a +4, you have a -9, so -5. So let me rewrite it and we're done. F of x equals x minus 3 squared minus 5. Let's go through graphing this one. We might not graph all of them, but just to review, 11, 6. My vertex would be at opposite same, so this one's going to change to a positive 3, negative 5. My axis of symmetry is going to be x equals 3. So if I graph this, I'm at 1, 2, 3, down 5. There's my, oops, I kind of missed there. There's my axis of symmetry. If I plug in 0, how big of a number am I going to end up with? Negative 3 squared is 9. Take away 5 is 4. So I know the point 0, 4 is on my graph. So 0, 1, 2, 3, 4. So this is 3 spaces away here. So there's a matching point 3 spaces away here. So 1, 2, 3. And so there's my parabola. And I'm done. So the only new piece that's added on for 11.7 happened in the first couple steps. Everything else from there on, the graphing piece is review. All right, so now I'm going to change this part up. I have a few examples to go through. So what happens if that is not just a nice old positive 1? And if you need to watch more examples, I'm sure there's more of these on YouTube from a multitude of math teachers, probably some on Khan Academy. You would just Google parabolas, standard form to vertex form, or complete the square to graph a parabola, and you'll see a lot of things. All right, 2x squared plus 12x plus 16. All right, so we're going to split it right here. I am going to pull out this coefficient, this a. Remember to complete the square. That has to be a 1. And my equal sign is here. So I'm not going to have one space on the left, one space on the right. Both spaces are going to be on the right-hand side. So I'm going to pull that 2 out. It's going to be x squared plus 6x, and then put a space, close that up. And then plus 16 and put a space. These two numbers are going to be opposites every single time. All right, so take that 6, divide by 2, it's positive 3. Square it, we get positive 9. We're going to put a plus 9 here. Don't automatically put a negative 9 here. Watch real quick. If we were, what did we really add when we put a 9 inside this parenthesis with a 2 out front? Well, if I were to distribute this, 2 times 9 is a positive 18. So what I really put here is a plus 18. So the number that has to go in the back that needs to be its opposite is a negative 18. So in the back, I'm going to put a minus 18. All right, but that part has nothing to do with the factoring. This 2 is going to come straight down. So I have f of x equals 2. This can be factored. 2 numbers that multiply to 9 that add up to positive 6 this time. It's always going to be that guy, x plus 3 squared. A positive 16 and a negative 18 is minus 2. We know this parabola is going to be narrow. It's going to open up. Its vertex is going to be at negative 3, negative 2. We know where the axis of symmetry is. So if on your homework it asks you to graph, this is why you did this whole process, to get it to this form so you could graph it easily. What do? if this number here, that leading coefficient, that a value is negative? Well, we know our parabola opens down, but it does kind of change some of what we do with the completing the square. So f of x equals negative 2x squared plus 8x minus 5. My equal sign is here. I'm going to factor that negative 2 out of those first two terms. So negative 2 parenthesis x squared. Notice if I pull that negative out there and that started off being a positive, when I pull a negative out, it's going to switch it. So minus 4x, because if I re-multiplied, it would change it back to a plus. And then I have a space right here, minus 5, and then a space. So this is the number I take half of. So over here off to the side, negative 4 divided by 2 is negative 2. Squared is a positive 4. So I'm going to put a plus 4 right here. And then I'm going to stand back and say, what did I really add to that part of my equation? Well, if I were to redistribute this number right here would be a negative 8. Negative 2 times positive 4 would be a negative 8. So in order to have opposites in the blanks, the back number this time is going to be positive. Let's go through that again. If this is a negative 2 times a positive 4 and you were going to distribute, you would have a negative. So in order for these two numbers to be opposites, the back guy has to be a plus. All right. Let's rewrite. We're one step away from being ready to graph it. So that negative 2 just comes straight down. Factor this. That's not really a part of my equation anymore. So when I factor that, I get x minus 2 squared. A negative 5 and a positive 8 is plus 3. My vertex is going to be at 2, 3. It's going to go down. It's going to be a little bit more narrow. And you can complete that if you wish, or you can just try it in the homework and check your answers with the back of the book. I have one more to practice. You might want to write it down and do this one as your try to see if you've got the idea on your own. Hopefully you've been doing some of that anyways. All right, and this time I put a plus 3 in front of that squared. So 3x squared plus 6x plus 2. Let's pull out the 3. So we get x squared plus 2x plus something. And then add the 2 in the back and put my other space. This is what we're going to have. So 2 divided by 2 is 1. Squared is a plus 1. If I multiply right here, I get a positive 3. So in the back, I should have put negative 3, if you're checking your own work here. This 3 comes straight down, so f of x equals 3 parenthesis. Two numbers that multiply to 1 that add up to 2 are 1 and 1, or that number right there, so x plus 1 squared. A positive 2 take away 3 is a minus 1, and we're ready to graph. All right, so what would the vertex here be? The vertex here would be negative 1, comma, negative 1. There is actually a shortcut that we're going to look at and utilize in section 11.8 when we look at application. I'm only asking you to learn one of the styles of application with quadratics just in the interest of time. So there is a shortcut that will allow you to go from here straight down to that vertex without going through the process of completing the square. And then we're going to utilize that shortcut. I feel a little evil waiting till the end, making you go through this whole process just to tell you there's a shortcut. But that is an important skill that reinforces that completing the square from 11.1. So I'm okay with it. All right, our shortcut is that x is equal to minus b over 2a, and then y equals whatever you get when you plug in that x value. So let's use that same exact example that I ended on. My last example was f of x equals 3x squared plus 6x plus 2. We know the answer is -1 comma -1 from my previous complete the square. Let me prove that the shortcut works. All right, so a is 3, b is 6, c is positive 2. So my shortcut says to do the opposite of whatever b is. B is a positive 6. So I'm going to go minus 6 over 2. That 2 is that 2. And a is a plus 3. So x equals -6 divided by 2 times 3. Well, 2 times 3 is 6. So -6 divided by 6 is -1. And in order to find my y value, whatever that x is I just got right here, I'm just going to plug it in for the function. So if I plug -1 in for x, y would be 3 times -1 squared plus 6 times -1 plus 2. Remember your order of operations, so do the square first. Negative times negative is a positive 1. Times 3 is 3. 6 times -1 is -6. Add 2. 3 take away 6 is -3. Plus 2 is -1. Notice those match what we got when we completed the square. So the shortcut totally works, and this is what we're going to use in our next lesson for the application questions. So I'll be right back. If you want to stay tuned for the next video, I'm just going to crank that out right here. Hopefully finish up the chapter today.